Today's topic will be the interactive dashboard, and we have seen the agenda as well. So let's know what exactly is Web GIS first of all. So Web GIS is something web-based geographic information system where we can create, analyze, and share the data. So anything which we have analyzed in the backend, the GIS data, putting it into a front-end visualization manner, that is all about Web GIS. So the shapefiles and the GeoJSON data, everything will not be understood by the non-GIS people, and also for explaining the entire project as a story map, WebGIS is very useful. Like we can describe about the objectives of the project and the analysis that is performed, the data that is created and calculated, and also the final outputs and conclusions. So all these can be integrated as a web map, which will make the user more understandable about the data. So WebGIS comes into picture in some of the applications I've listed, like urban planning is one of the main field where WebGIS is more useful, like the smart city development. In that, actually, we can um, if we are showing any of the water pipelines or something, we can highlight it in a blue color and show the map, so that can be highlighted. So there's an easy way to visualize the data in WebGIS, and also the transport routes, like Google Maps is the best example for WebGIS application. So all the shortest route calculation and the time calculation, everything will be done in the back end by the developers itself. But in the front end to the user, only the shortest distance and the time will be shown. So the final conclusion will be shown on the web page. So this is where WebGIS comes into picture. And also in the disaster management, the risk prone areas can be highlighted as a red region. So we can create a web application where people can actually log in and check which are the risk prone areas, and they can move into safer zones, which will also be showcased in the web map itself. So it enables the users to understand more about the data. And in the environmental mapping, so what has changed within the time, so the time series analysis can be shown in WebGIS. Like if we take a particular region and we calculate the number of trees and the change detection we can do, like how much it has changed within the time. So in the environmental monitoring, we can showcase the time series web application. And in the business intelligence, we can show data analysis reports like a dashboard, which we'll be learning how to do it today. So this is the applications of WebGIS. And coming to an interactive dashboard, what and all can be done in a dashboard is it's actually a way of representing and displaying the information, like the data in a better visual manner. So we can monitor and analyze the data based on multiple factors. So a dashboard can have multiple charts, like a bar graph, a line chart, and many more. I'll be showing that in the later session. So it's a visual display of data that responds to user inputs. Like if we click on a particular data, what will be changing on the dashboard or on the chart. So that is all about the dashboard. And the dynamic charts and graphs will be integrated. Filters and selectors on the data, like for example, I told you the time series one. So we can apply a filter like from this year to this year, like from 2020 to 2025, what all has happened. So we can add the filters as well. And the location based selection we can do. So example, like within this like in Karnataka, how many COVID cases are done, so that is location based selectors. And the real time or live updates, so this is about the IoT integration. We can capture the live data and perform the data analysis and capture the data from database and show it on the front end web application. And also like climate changes, which is a real-time data, we can upload it as a web page or the dashboard, the analysis. And use cases I've already explained. So in today's webinar session, for creating a dashboard, we'll be using technologies like HTML, CSS, and JavaScript, which are completely front-end technologies. And we are using a Mapbox. Already a webinar was conducted on Mapbox Studio, but I'll just be showing the interface today. Mapbox is a cloud platform where you can host the maps along with the styling, and also fetch a link and add it directly to the website. And Plotly is a Python and JavaScript combined library, which is mostly used for statistical data analysis and also for visualization. And Dash is a library, Python library, which is for backend integration, and also charts can be created using the Dash library. So we'll get into Mapbox first, and then we can see how the maps can be. Yeah, so this is the Mapbox Studio. As I told you, Mapbox is a cloud platform. Here we can add the data, publish the data, and use it on our web pages. So Mapbox also provides you a studio where we can style the data. So I'll be just showing the entire process right now. So first I'll be telling about the access key, that is the public token. When you create an account for Mapbox, you'll have an access token which is unique for each user. So this token, we can use it to publish the web map. So this is very unique for every user. And coming to the data manager, so this is where we can add the shapefiles, GeoJSON files to host it on this cloud platform. So tile set, here you can see an option called new tile set here. So new tile set, as you can see, there are multiple forms of data which is accepted in Mapbox. That is, for vector data, you can drag and drop a GeoJSON file or a shapefile. It has to be in a zipped format, KML, GPX, or a CSV file. So these are the vector file formats which are accepted in Mapbox. And for the raster data, you can use a geotiff file. So I'll just select a file. So this is my GeoJSON data, Bangalore stations. So I'm opening it, and we can confirm here. So this is how you add one shapefile or a GeoJSON file into this cloud platform, and it takes a few minutes to get uploaded. Here you can see in the notifications panel whether it is uploaded completely or you have to still wait for a few minutes. So I'll now show an already uploaded districts data, since this uploading takes time. So this district data I've uploaded previously. So this is the Karnataka districts data here, as you can see on the map. So all the attribute information we can see on the left hand side below the vector layers. So this is the columns which are there in the GeoJSON file. Yeah, this is about adding the data into the cloud platform. Now we'll see how to style this particular data. This is a style editor, as you can see in the left side panel. In the style editor, we can add styling to each map. So there are many options in Mapbox Studio, and we can export the map data along with the styling. So this is the style editor, and here we can see the new style option is there, and we'll just click on the arrow below it. So this is where we can upload the style. If you have already created a map and styled it in QGIS or ArcGIS Pro, we can export the SLD format style and convert it into JSON format. So this is where we can upload the JSON here, the styled JSON. So we'll not get into this right now. I'll show you how to style a map from scratch. So classic template is something where we can have multiple kinds of base maps. So here we can see the street view. The right side there is a preview here, and in the monochrome we have multiple base maps as styling. So there's a dark mode and sky, golden, and many more you can explore. And outdoors data is Yeah, outdoors data is where we can see a 3D mapping, and also the contour lines will be visible, and the navigation base map, night and the day, two different base maps are given here. So we'll be using the monochrome dark mode for now. You can use any of the base maps according to your necessity. So after choosing a base map, you cannot change it later. So while choosing, be aware of what kind of data you're using. So this is the base map that we got by choosing on the style section. So if you can see, there is a layers panel here on the left side, and here we have add new layer. So we'll be just adding the data which we have uploaded right now to the cloud. So add new layer. In the custom layer, in the source, so here we'll just search for the data I've added, that is the districts. So I got this layer here. So this is the data I've uploaded, as you can see. And here the styling part starts. So in the type, we can change the fill of the data. So for example, if I provide line data, only the outer boundaries will be visible. And if I provide the circle, the outer boundaries will be in the shape of circle. So this is about the boundary styling. And when I come to zoom extent, here we can set the extent from where to where the map has to be visible. So this might be very useful in WebGIS because not every map should be visible in every extent. So when I come out here in the left panel, I've highlighted, here we can see the zoom range. So right now I'm at 3.79. So I'll just increase the minimum zoom range. So now you're not able to see the data, right? If I zoom into 4 also, you're not able to see the data because I don't want to see the data in this zoom level. So only when I go until 11, the data will be visible. I'll just reduce it to 4. So now you can see the data. So for now, I'll be taking the fill option, and let's get into the styling, the actual styling part. I'll quickly change the color of the fill, that is the red color, and we can also change the styling based on the data range. So you can access the attribute table of the data that we have uploaded, and we can change the styling based on that. So here you can see, I'll just quickly change the color of it. So if the data, I've given the column as ID2, it just has a random numbers. So if the values are between 206, then the area will be colored white, and the highest value is 232, so the colored value will be dark red for that region. So for whichever the values which are in between 206 and 232, it will automatically allocate the color based on the accuracy, like how much far the value is. If it's 210, it will be like whitish itself. If it is 230, it will be a light red in color. So this is how we style based on a particular column. The color is changed based on a particular column. So now let's see based on zoom range how we can change the color of the map. So this is how we change the color based on zoom range. So fill color based on zoom range. Now it is 0 to 22. I've given these colors. So I'll add another step. So here there is 5.67. This is the zoom range. And for reference, I'll add one more step. So this will be approximate 3, and this will be around 8. This can be any values based on your stylings you can give. So in the zoom range of 0, let it be white to red. At 3, I'll be changing it to green to just show you like how the color changes. and at 8 I'll be changing it to blue or something. Yeah, I'll go with the dark blue for differentiation, and at the 22 let it be something like pink. So this is a process of changing the colors based on zoom level. You have to click on the zoom range, and here you will have options to add the stops, like the zoom range values, and here we can change the color. So here also we can add another step. So since I'll just show you the range of values, this is enough for me. So now let's see how it has changed. Let's zoom out. um, in the select data, I've given the zoom extent to 4.3. Just quickly make it to 0 so that we'll be able to see the map in any zoom extent. So now, as you can see, the zoom level is 4.41 right now. I'll zoom out to 0. Now it is 1.52. So you can see it is in the red color. As I've given from 0 to 3, it will be in the red color. And when I keep zooming in and the zoom level changes to 3, so we can see the green color. And when we zoom in more, it will be changed to like until, yeah, when it reaches 8 or something, it will be to pure blue color. So this is how we can style the data based on the zoom range and the data range. And also we can change the opacity, that is for the line data. I'm now using fill color, so that doesn't count here. So yeah, this is about styling a map in Mapbox Studio. I've not explained everything in detail because there's a YouTube video available on AGSRT official page where it is already explained, so you can visit there. So I'll now show you how to publish this data so we can use it on our web page. So here is a publish option on the right corner. So I'll be clicking on it. So you can see the current map and the what has to be changed. So it's a bit slow due to my Wi-Fi issues. So now if I give the publish option, it is successfully published. So you can use this on a cloud platform. You need not carry this shapefile or the GeoJSON file anywhere. You can just access the link and use it anywhere when internet is provided. So there is another option called share here. When I click on it, we'll have a link here. So the published link, like I've told you, the preview only. So I'll copy this link and paste it on my browser. So here you can see the published output. So map center I have not, maybe it is not published yet. It is done, I have to refresh. This takes little time to get uploaded to the cloud. See, as you can see, my map is now published. It's still getting published. Like it takes some time since it is a cloud platform and I've used a large data set. So this is the final published data. So using this Mapbox link, you can add this map anywhere. For now, I'll be using it on HTML page. So yeah, this is about publishing maps in Mapbox. So using this Mapbox Studio, we have created few story maps that I'll be showing you right now. So we have performed an analysis of change detection for a particular region that we have selected, that is Dayabasi, New Delhi. capital of India. So this is the railway station we have taken for change detection process, and we have created a web story map which will tell us all about what data is collected, how the data is collected, and analysis what we have performed, what are the conclusions done using the change detection project. So this is the application of WebGIS I was talking about. So once the map is styled in Mapbox Studio, we'll bring it on to a web page. So this will provide us more insights about the data that we have analyzed. So this is the story map. We have provided the theory content for understandability of the client or the user. So this is the flow chart that we have given what and all process is done in the change detection project. So this is the flow chart, and this is the region that we have selected, and yeah, this is the layout used from Mapbox Studio. As you can see on the right corner, it is Mapbox, and wherever you see this Mapbox icon, which means the map is used from the Mapbox cloud platform. So this layout provides us like visibility option, like just in one layout we can view two different maps. As you can see on the left hand side, there is just the boundary I've added. On the right hand side, it is the entire NDVI analysis output that we have added. So using this layout, we can visualize two different maps on the same layout. So this is the same analysis that we have done, and we have also added the legend on the right bottom to tell the user what the data is about. So the water body, railway track, everything is the description is provided in the legend itself. As you can see here, two different maps are there. On the right side, it is the 2023 NDVI output, and on the left side, it is 2018 output. So at the same time, you can easily compare both the data using this Mapbox layout. So this is the story map that we have created. Now let's get into the sample dashboard that we have created for this change detection output. So this is the dashboard. This is the area we have considered for the change detection, and this is the digitized data. And we have classified as official buildings, unofficial buildings, and the trees here. As I've provided a pie chart, you can easily know what color is which data. I'll show you the red part. When I click on the pie chart, a red color, only the official buildings of the data will be displayed here on the dashboard web map. So when I click on the unofficial building, the how many number of polygons are there, the count is changing, and the total area is changing. So this is about the unofficial data. And the trees, when I click on trees, only those polygons will be shown here. And also the polygon count I've integrated as a line chart, and area is also used with the line chart. So this is a simple dashboard that we have created for the change detection project. So there are another applications of the WebGIS also. We have posted it here. I'll just show you. So this is a web map that we have created using Mapbox and the Plotly library, which I showed you like in the webinar agenda. So this is about the student admission details of AGSRT company. So from where and all students are getting admissions at AGSRT. So we have picked up the location and shown it in a beautiful way as a web map. So you can see it is animated, and this red location is the AGSRT office location, and the yellow points are the student locations. So this is how you can, this is actually taken from a CSV file. So if we just showcase a CSV file to somebody, it is not visually like understandable to people. So when we create a web map like this, it is more understandable, and it is it is also like providing a better visual way. See, there are students from New York, United States, Los Angeles, so these everything will be connected to the AGSRT office location. So this is how you can showcase your data more. Yeah, so this is about the web map. So now let's get into the dashboard example, and the live demo will be creating it today. So this is an example dashboard we'll be creating today for the GeoJSON data. So this is the dashboard wherein right hand side you can see the map that I've taken from Mapbox Studio. Here you can see it is a Mapbox. So I have published this layer on Mapbox Studio and fetched the data from the studio. And you can see the point data here, which is Bangalore stations that I've taken. Before this, I'll just show you the data which I'm using, the attribute data. So this is a point data I'm using. In the attribute table, we have columns like station names. So each point is having multiple columns, like multiple rows here. So for each day, the CO value, that is and the ozone value, NO2, NH3 values, everything is calculated for each day, as you can see in the date column. So for the same place, we've calculated the atmospheric NO2, NH3, SO2 values. So and also the AQI value. So AQI value also we are using on the dashboard. So this is station, we have grouped the data based on station NA on the dashboard. So this is about the attribute table that we are using for the dashboard creation. So now let's get into the dashboard explanation. So I'll just give you an outline of what this is. So when I click on the veterinary college, this point, the dashboard gets updated based on its attribute data. And when I click on the next point, that is Nisarga Bhavan, so you can see that the NH3 content and the ozone content is changed here. And when I go to the Majestic, it is changed, and the Mysore Road, it's getting changed. The NH3 content and also the ozone content is getting changed dynamically. So coming to the map, we have used a point data, and these points are colored based on the AQI values. AQI values are present in the attribute table. I've shown the column. So these colors are specified based on the AQI values. I've taken from 0 to 100, and as you can see, Veterinary College AQI value is 73. So its color will be green. So likewise, for every point data, based on the AQI values, I've given the color. So we'll show this all in the coding part. Now coming to the chart wise, ozone content, this is a God chart which is semicircular in shape, where I've provided values from 0 to 100. So this will fill according to the attribute information. And the next comes the AQI chart. This is a line chart. This line chart will have the values from the attribute table which is fetched. This is grouped based on the station NA values. When I hover on the point, we can see the station names as well. And there is one more option in this dashboard, that is we can download one particular chart as a PNG. So I'll just quickly show you how to do it. When I click on this camera icon here, so it is downloaded. I'll show you the PNG format. So you can see an individual chart being downloaded. So this is an option provided by Plotly, a Python library. We'll see how it is done. And also there is an option for zoom in and pan, box select, and zoom in, zoom out options, auto scale, and reset axis. When I just zoom in to a particular area, and if I have to come out of the zoom region, we can go to reset axis. And also we can see here that the chart is produced with Plotly, and for the documentation you can click on this icon and you can see what are the other options provided by Plotly. So this is the line chart, and in the NH3 chart this is just a text displayed. Based on the attribute information, it gets changed. Coming to the NO2 content, this is a pie chart. This pie chart shows the NO2 content values of each station area. So as you can see, I've also provided the legend, and when I hover on it, its attribute information will be displayed here. So based on station NA, it gets changed. And the CO content is the bar chart. Bar graph also we have grouped based on the station NA content, and when I hover it, it gets like its attribute gets displayed here. So, and if I want to zoom in, I can just zoom in like this. So this is how we can interact with the dashboard. This is called an interactive dashboard because when I click on the any point here, the NH3 content and the ozone content is getting changed, and also we can zoom in, zoom out options are there. We can download it as a separate PNG format, and also when I hover, the attribute information is being displayed. So this is all about the interactive dashboard. Now let's see how this is created using the front end and the back end coding. So let's get into the coding part here. So this is the Python code I've used for developing the dashboard I've showed you right now. So this one, it's not completely based on HTML CSS. So it is Python backend connected application. So Dash is a library which provides a backend functionality. It is actually a framework. So from here we can host the web applications. So we'll start with the import statements. Since we are using the Dash framework, we have to import the Dash framework. It's mostly used for building the interactive web applications using Python, independent Python. And we may not use HTML CSS here, but I have used for more visual, better content. And from Dash we are importing DCC. DCC is Dash core components, which will have inbuilt functions like pie chart, bar chart, and GAW chart as I showed you, and the line chart. So one advantage with Python is we need not code entire thing line by line. There are many more inbuilt functions which are already predefined and coded for us. We just have to import it and use it as a function. We have to provide the parameters as what we need from the attribute table. So from Dash we are importing DCC, and also HTML page also we are importing, and importing pandas as PD. So after accessing the attribute table from a GeoJSON file, I'm creating few modifications on the data analysis part I'm doing, for which I'm using pandas. So as you all know, pandas have two kinds of data structures, that is series and the data frame. Series is something which is a kind of list or a continuous data, which is one-dimensional data, and data frame is two-dimensional data where you have rows and columns. So we'll get into that later. And we are importing Plotly.express as px. So as px is the aliasing we are providing. So when you're using Visual Studio Code as a code interpreter, you can see that when you just hover it on any particular library or the function, there is a description given on top of it. So, and the documentation is also given. If you want to explore more about it, you can just visit the website and do that. And Plotly Express is submodule of the Plotly library. It is more used for the developing charts and graphs as I showed in the dashboard. And Plotly graph objects as Go. This also I'm importing, and I'm importing JSON because I'm converting this GeoJSON spatial data into JSON. Without that, also you can perform analysis, but since the accessing of the attribute will be faster, I'm using JSON format. So the next is loading the GeoJSON data. So I'm using the Bangalore station .geojson file that I showed you in QGIS, and this with is a keyword in Python which we use to which we use in file handling to open the file, read file, write in the file, append more. So with is a keyword which supports in file handling in Python. So I'm using open function, and here we have to provide the location of the file we have to use. I have provided just the name with extension because I'm using it in the same folder. If your GeoJSON file is in the different folder other than the one you're using, please provide the entire location, not just the relative location. So yeah, this is about GeoJSON data, and I'm opening this file as f. This is also aliasing, and I'm passing this entire data as f into a geojson.load function. This function will actually access the GeoJSON data that I've given, access its attribute column and its values, and it will convert it into JSON format, and it is stored in the GeoJSON data. This is a variable that I've created. And now we'll see how the extraction takes place. So as you can see, we have to extract the feature properties from the attribute table. So attribute table consists of rows and columns. So this cannot be accessed in the form of list. So this is where we use pandas data frame. As I told you, data frame consists of rows and columns. So here in the GeoJSON data, where the JSON data is that is just a variable I'm telling you, and where GeoJSON data is loaded, features is one column that we are accessing here. So in the features variable, this data will be stored. And the next is we are performing list comprehensions. List comprehension is where in the for loop we are accessing each properties of every features data. I've created a variable called features in the above line and accessing its every line. So every list in it is accessed and it is created as another list. So list inside a list. So it is all stored in the records variable. So in the records variable, we'll have the list inside a list. So the next is converting this list data into a data frame, that as I told you in the form of columns and rows. So pd.dataframe is a function which creates a data frame out of this list. So records is created as a data frame and stored in a variable called df. So df is the final data we'll be using in the further code. So df contains all the attribute data of our GeoJSON and it is stored in it as a data frame. So now the next step is I'm actually calculating the date, the recent date. Since I've showed you in the attribute table, multiple dates are there. For each day the values are calculated. So I am using the most recent one. Like for the veterinary college data, most recent data will be 30th April 22. So I'm using this last data, I mean the most recent data. So for calculating that, in the if condition I've provided, if date is a column that I'm using in df.columns. Df is a data frame which consists of all the attribute information right now. So dot columns will give you, df.columns will return you entire column data in the attribute table. So in that we are accessing the date column. So df of date is equals to pd.do to underscore date time. So here we are accessing the date of every individual rows. And in the latest underscore df, this is a variable that is created again. So here we are storing the maximum value of this date. So maximum value of this date will obviously be the most recent one. So here we are copying it into a latest underscore df variable. And next, so latest underscore df will have the attribute information of the most recent date, and in that we are taking station short. This is the column we are creating because as I've shown you in the dashboard, here if I give the name of every station NA, it will occupy more space as I've given in the pie chart. You can see the entire station NA is being displayed in the pie chart because I have space here. But in the line chart, I do not have space. So this is where the pandas comes into picture. You have to design the dashboard in such a way that it has to provide um, like easier way to understand. If I provide more text here, it will occupy more space and it will look a little clumsy. So I have shortened the station NA values. So here we are using a lambda function. So this dot apply, and we are using a lambda function here. We are splitting the station NA values. In the station NA, we are actually taking the first word. So if it is city majestic, then we'll access only the first word, that is city. So uh, x dot split, where each station NA, that is station name, is being taken in the x parameter. Dot split is a function where if you don't provide anything, by default it will take space as the delimiter, and we are giving 0 as the index value because we need the first word we have to take. So now the latest df of station short, this will contain the shortened names as I shown in the line chart. And now when I load the dashboard, I just reloaded. By default, I need some values to be displayed in the dashboard. Like since it is interactive, when I click on veterinary, its value is shown, and when I click on Nisarga Bhavan, its value is shown. But when the dashboard loads and I have not clicked on anything, I have to show the default value. For that, I have picked the first point value, that is veterinary college. That is the one I'm showing in the code right now. So I'm picking the veterinary college, Hebbar, this station name as the default station. So whenever the page gets reloaded or something, this is the default value that will be shown. So now if the station NA is equals to the default station, so that data will be stored in the default row. So it's the same. I'm taking the station NA here, and its corresponding ozone value, NH3 value, will be updated in the dashboard. So this contains the entire row values. Now we'll get into how the charts are created, like the pie chart. We'll first get into the NO2 pie chart. In the NO2 pie chart, I'll show you. See here, this is the pie chart we have created. So this will provide section for each of the grouped station NA values, and the legend is provided outside the pie chart because I have more space here. So it depends on how you have to design the dashboard. And these percentage values are how much area of pie chart it occupies. So the highest will be this majestic one, 27.9, and this is how the percentage for every other station names will be calculated. So we'll now see how to create this NO2 pie chart. So fig underscore NO2 is the variable I'm using right now. So px.py, as we know, px is the aliasing name we are using for Plotly Express. So Plotly Express, as I told you, it consists of many inbuilt functions. The code is already written in the functions, and we just have to use those functions, providing proper attributes or the function parameters. So for this px.py, this will create a pie chart. For this, I'm giving parameters like latest underscore df. This is where the entire attribute information of the latest date is being picked. So it consists of a series data. So then that is the first parameter data I'm giving. In that data, which particular column should be used, that is given in the values parameter. So for NO2 pie chart, I'm using NO2 underscore UG underscore M3. This is the column name that I'm using. So that one we have to pass in values. And this is the names based on what we are grouping the values column. As you can see in the dashboard, the more pie chart is created using the NO2 columns, but in the labeling we have used the station NA values. So this is how we have done. And this whole 0.5, this is the middle gap that we are getting, the 0.5 is the radius. If you don't provide this whole as a parameter, that is totally fine. It will create an entire pie chart without this gap. So this is the .py function of Plotly Express. Now we'll see the styling and attribute of this pie chart. Fig underscore no2 dot update underscore traces. This function is used to add the attribute and perform analysis for the already created pie chart. So the first attribute we are using is the text info. Text info is what should be displayed on the label. So as you can see, I have given text info as label plus percentage. So what is the label that we are using here? That is the names, station names column. Along with that, we need the percentage also. So in the text info attribute, we are passing the label and percentage. So next is text position. Text position is where the legend has to be shown. It has to be outside or inside. Since I told you I have more space and I need a better visualization, I've provided the legends outside. So text position will be outside. And pull is equals to 0.05 into length of latest df. This is the pull is an attribute where you can see that the orange color, that is the highest value, is being pulled out more in the pie chart. As you can see, it's not completely visible, but yes, the orange color one is pulled out since it has the maximum value, and that is where we have given here that is what we have passed, 0.05 into length of latest df. So that is a pull parameter. And the text font, this can be changed based on your needs or the visual requirements. So I've given Arial narrow, that doesn't matter which font you give, but it matters in bar graph. Like here, the text is too long and you have to give a font style such a way that it is little compressed. So that is based on your requirements again. So again, next is the background color we are giving for the layout. So fig underscore no2 dot update layout. Here we are giving the background colors. Like this is a attribute we have to pass for background color. Paper underscore bg color, plot underscore bg. Paper underscore bg color is the inside of the pie chart. Other than these colors, what color should be there? Plot underscore bg color is the entire pie chart background. So both have given black, and the font color is given white. Title font color is also given white, and the margin. So this is a dictionary I've passed top, bottom, left, and right. All I've given 20 px. So on all the four sides, it is given space of 20 px. And show legend I've given false because I've explicitly added station in it, so I don't need the legends. If you add the legends, you will get on the right hand side with the color boxes what is the station name. So I don't have space, so I'm not adding it right now. So this is about no2 pie chart. This is complete code for the pie chart. Next we'll see the bar chart. Bar chart is for the CO content. As you can see, when I hover on it, we'll get the attribute information of that. So that hover options and all is provided in the last, so we'll go through that later. Now it is just how to create these charts. So in the CO bar chart, there is again I've told you there is a Plotly Express inbuilt function as dot bar. So dot bar already has a predefined code within it. So we just have, see, this is the dot bar. So x, y values can be given, color, pattern, shape. So when you hover on this function, you'll get all the information about the function. So this you can explore it. So for now I'm creating the bar chart based on latest df sort values. Sort values is a function which sorts in ascending or descending order. As you can see in my bar chart, we are giving values we are arranging it in the form of ascending order. So first Silpur has 0, so it is in the first, and the value gets on increased. You can see the value here on the hovered option. For Nimans it is 0.38, and for Hebbard it is 0.39. So as you can see, it is arranged in the ascending order. So this is the column that I'm using for creating the bar chart. So it is co underscore mg underscore m3. So ascending I've given as false. So the next is x value. So in that x value, we are passing the value that has to be shown in the bar chart, and like what on what is the plotting basis, like what is the x axis value and what is the y axis value. Here I've used x axis as the co values and the y axis as the station names. And orientation is h, it provides the horizontal bar graph. So next is height and width of the bar graph, set. And in the next we'll be seeing about the update layout of the bar chart. So here also we have provided the similar functions that we have given for the pie chart, that is paper bg color, that is inside the bar graph what the color has to be, and the plot background color, that is the entire section of the bar graph which color it has to be. And the next margin I've given in a dictionary as left, right, top and bottom as values. So left side I've given 60 because I have to name it based on the station NA value. So I need so much space there to display all my station NA values. So that is the reason I've given 60 on the left side. So font, I've already told you, you can use it in a font family. X-axis title I've not displayed since I did not have space here, but you can actually add in a horizontal way. You can add a column name like station NA will be on the y-axis and CO value will be on the x-axis. So this is about CO bar chart, that bar chart I've created. Marker line width is the outer boundary for these bars will be given, so that I've given as 0. So this is about the bar chart. Next we'll be seeing the gauge chart, that is the I've given for the ozone. So for this ozone we'll be using the Plotly.graph objects that we have imported as GO. When you see in the inputs aliasing we have used as GO, so you'll be using this shortcut. So for creating ozone, we are using the gauge chart. Here as you can see, go.indicator function I've used, which creates a gauge chart. Inside that we have to provide parameters like mode, value, gauge and the title. So in the mode I've provided the gauge value along with the number. I'll just show you in the dashboard. We'll go with veterinary. So as you can see, the label is given 0 to 100 and the gauge value is given, and its value is also displayed as a number. So that is what gauge plus number. So the value, the default row will be ozone UG underscore. This is the column we are fetching from the default row. The default value I have given only to the ozone content and the NH3 content, because in all other charts and the graphs we have values for all the station values. Station names. So this will not change dynamically. Only ozone content and NH3 content I have given default values. So from the default row we are fetching the ozone value. So when I click on the different point data, it will get updated dynamically. And in the gauge, I've given access range 0 to 100. You can see it here. It is from 0 to 100. You can change it according to your data needs. And the color fill inside it will be blue. You can change it to green. And for that to get updated, I have to rerun the code. We'll see that later. So this is the title I've given, that is ozone content, and also in the update layout providing the stylings for these God's chart, that is ozone chart. We are again providing paper background color. The one thing you have to keep in mind when creating the dashboard is it's like the data has to um, showcase well. It's not that you're using more number of colors or using less number of colors. It is just that how the data is being visualized. I'm using a standard blue color here, entire dashboard, other than the pie chart. This is just to provide the differentiation between station and A's. So here I've used blue color for everything else. So the standard layout has to be followed for dashboard. It should not be too many colors should not be used. And okay, unless required. If it's required, you can use it. And for the background color, I've given black, and the height is 320, width is 250. This will all come under the styling, how big you need, how small you need. Based on the layout, you can adjust the values there. Font color I've given white, and the title font color is also white. This I'm keeping it standard for all the charts. And margin, that is top and bottom, I'm giving it a 20 and a 40. Top I've given 40 because the title has to take space over there. And the font I'm keeping it constant for all the charts since it has to look better on the dashboard. So this is about the ozone chart that we are seeing in the dashboard. So next is the AQI line. That is the line chart. The line chart is also being taken from PX, that is Plotly Express. So dot line, excuse me. Dot line is a function which also has inbuilt code, and we are passing functions such as parameters such as the data, x value, title, and the markers. So here we are using sort values based on the station names, as you can see in the line chart. We are sorting it based on the alphabetical order, not based on the number. Here in the sort values, whichever column we provide, based on that it will be sorted. Now if I provide AQI here, so the chart will be sorted based on the AQI values, but I want it in a alphabetical order, so I've given the station names here. And the x-axis for this will be station short, the short and the name. Y-axis will be AQI column from the attribute table. So the title, I'm giving it as AQI by station. Markers is equals to true. Markers true means we'll have this circles, that is the point data, that is the markers. This is creating line chart, and for the styling we'll update the layout, that is height and the margin I've already explained. Background color is black. Plot background color is also black. Font color, these are the constant functions. We'll be using it for all the charts because dashboard is all about styling and showing the data in a better visual manner, so this all should be constant for all the charts. And show grid false I've given because yeah, grid is nothing but in the bar chart, these are the lines in the middle. So if I show the grid as true, then we'll have lines here in the line chart. Grids will be enabled, so I don't need them, so I've given it as false. Later we'll check if we give true what will be the output, because I have to rerun the code continuously. I'm not doing it right now. I'll show it later. So next is the NH3 value. In NH3 value, as I told you, for ozone and NH3 we are using the default row at the first. So NH3 is the column which is fetched from the default row series data. So this will hold the default value. Now this is all about the charts that we have created in the dashboard. I've explained all the 5 charts. So now we'll get into the map. That is how this map is integrated here, how the on-click functions will work, and how it is dynamically changed, and the hover options. So we'll look into that part now. So first, locations is a variable where I'm fetching properties of each station values. That is the first column that I'm using. So Z values is again a list I'm creating, like for location, for LOC in locations. I hope you all know what for loop is. So here I'm fetching the station NA values based on LOC and fetching each AQI values. I'm doing this because based on the AQI values only I've given the color for each of the point data. So I need to access the AQI values along with station NA. So that is, after accessing it, I'm storing it in a Z values list. So here I'm appending the values of first index. So this is how I'm fetching the AQI values and the station NA values together. So fig map. So this is the start of the map. Go.figure. This will initialize a figure or the map in which we can add any kinds of maps, any number of maps. So this is the template. This is kind of a template function. So now at the polygons layer, we are actually using the point layer here, and fig map, I've told you this is the template we are using. For you people to understand in a better way, I'm using words like template, but this is actually a function. Figure is a function. So add trace is a function which will take these parameters, like what color has to be provided. I'm using Choropleth Mapbox. This is function taken from the Mapbox as well. This is, we need not import Mapbox or something from anywhere. So this is one I'm using from Mapbox. But we have to provide the access token, which we'll see in the later part. So in the Choropleth map, I'm giving the colors as I showed you in the dashboard. So GeoJSON data, that is the data we have to pass. GeoJSON data is a variable which consists of, which holds the JSON data we have fetched in the previous step. Locations is, we have fetched it in the list format. And the Z values we have fetched AQI values. And the feature ID key, properties.stationNA. In the properties, which particular column we have to use for the plotting on the map. We are using the station NA column. And color scale. Color scale, you have multiple options. I hope you all know it because it is also used in QGIS and ArcGIS Pro. So it is color scale. We can give any. We'll have options as well. So I'm using the where it is. And the marker opacity is 0.2. Opacity and all you can change based on your requirements. And the marker line width, line color, I've given white. So yeah, show scale is false. So this is how we have created the choropleth, that is the right hand side color based legend. So yeah, this is about styling the legend. And next, hover text. So scatter points are nothing but these points which are showing on the map. So we'll see how that is being styled. Latest underscore df consists of all the data frame values as I've explained before. Dot apply lambda. Lambda is a one line function where you need not call function multiple times. Since it is only used once, we can use this lambda function. So here we are passing each row, where in a f string we are passing, this is just for labeling part. In this f string we are passing station NA, that is the station names, and break, this will move to the next line, and AQI values are displayed. This is the hover text variable which stores on this. When I hover on a particular point data, you can see that station NA is visible, and in the next line AQI value is also visible. So this is about the hover text. And in the fig underscore map add trace, will be providing more styling for this. In the scatter mapbox, go.scatter mapbox, I'm providing lat long values for the point data. It is taken from the latest DF, that is the GeoJSON data. And mode will be markers. Marker is go.scatter mapbox.marker. This is for the marker styling, explicitly for the circles. So size will be 12, we can also increase it. Color will be based on the AQI value that we have taken using the choropleth. And the Color scale is where it is. This already we have declared. And the Cmin and Cmax value, you can see here, minimum is 0 and maximum is 100. So this is how we have used. And the color bar, opacity, show scale. So text, we are providing the hover text. In hover text, we have dynamic content, that is to whichever station in it is pointed, its AQI value will be displayed. So hover text will be a dynamic content. Inside the hover info, we are passing this text information. So this is about the map. And in the update layout, this is the above function is about the map, and this update layout is about that particular section of the map. Now the map box comes into picture. Map box style, that is light. As I showed you in the Mapbox studio, we have multiple base maps like satellite view, street view, monochrome light, monochrome dark. So those are the multiple base maps that are available in the Mapbox styling. So now I'm using the light, as you can see in the dashboard. This is the light color base map I'm using. In the Mapbox access token, so this is the access token. I've told you that you'll have a unique value for every account you create in Mapbox. Mapbox is actually free for certain number of data, so you can use it and explore for. It's very useful for Web GIS. So this is the access token, and the zoom level I've set it to 10. You can change it dynamically as well. Mapbox center, that is when I refresh the layout, that is the map, where exactly the map should show the first time. So this is the center, Bangalore center coordinates I've given. So that is the reason it is taking center. And this lat long values I've not given as a static value, it is dynamic, that is it is calculating mean value based on the lat long. Lat long values are present in the attribute table of the data. So this is how we'll be seeing the mean value we are calculating, and then we are actually calculating the center of the map. Height I'm giving 900, and the margin is all 0 because I want the map to entirely fit in the container. Paper background color is black, and the font is, as I told you, I'm maintaining the consistency. So next, this is all about the map. On the right hand side you're seeing in the dashboard. So this is how I have taken the help of Mapbox cloud platform. I've taken the base map from it, and also the styling part as well. So this is how Mapbox is useful. And the next is initializing the dash map. This is where the backend code comes in picture. So Dash, as I've told you, it provides the backend framework for creating this web application. So dash of underscore name. This creates an app. You have to declare this before starting to create any of the map. So app, I'm providing a title for it as Bangalore AQI dashboard. As you can see, the dashboard here on the web page above. So this is the title. And app.layout. So this is where actual HTML comes into picture. So we need not use HTML, but for the actual layout, if you have to design exactly like a dashboard, we can use this. Otherwise, if you're not using this HTML.div and all, so you'll have the charts created, but it will be one below the other. It will not be in the form of dashboard structure. So this the above code, whatever I've told you, that is all for the charts and the map. From here it is all about the HTML page. So it depends on how you need the dashboard to look, whether the map on the left side and the charts on the right, or which chart has to be placed where in the web page. So it is all depends on your user requirement. So we'll get into the HTML part. Excuse me. So in the HTML part, app.layout, this is where we have to integrate all the HTML div and its functions here. So HTML.div, that is the entire div where background color we have given black, and in the entire page we need color to be white, and height I've fixed it to 100 viewport height. In the children, so this is the parent div I'm declaring. Inside that we have multiple divs. So HTML div, this is the child of the parent div. Parent div is the entire section. So the first child div is in that left container with top and section stacked vertically. Left here I've divided the left container as this particular dashboard I'm showing right now, and the right child is the map and the its legend. So in the HTML.div left container we have two more sections, that is the top container and the bottom container. We have still more divisions, so we'll look into that in the code. In the top section we'll see what are the things we have added. In that we have fig underscore ozone as the first chat. So HTML div, inside that we have created one more segment. So this is like a top section, a container inside a container. So here we have used DCC. DCC, as I've told you, it is a dash core components. So this will provide you inbuilt functions to create graphs and all. I've told you already. So also for the placement, it is more useful. So dot graph is a function of DCC. Dot graph is a component of DCC. So here, which is the figure we have to attach? Fig underscore ozone. This is the one. For this, I'm providing a class name as subsection ozone. Excuse me. So class name, it can be anything you wish. So the next section will be AQI line fig. So as you can see, after ozone content, this is all inside the top section itself. So after ozone content, it is a AQI lines. So for that, I've given the class name as subsection AQI. Next one is the div, HTML.div, where I've given the NH3 content. This is the heading that I've given, NH3 content, and this is not a chart, this is just a text displaying. So I have to explicitly declare here as HTML because I've not used it in the Python code. H3, I hope you know, we have H1 to H6 text sizes in HTML. So H3 is the medium size, so you can change it as well to H1 to H6. So in that style I've given margin bottom up 10px. And next HTML.h1. This is where the value is displayed. See, NH3 content I've displayed in H3, HTML.h3. So it is, the size is little less. But this value I've shown in the H1. So it is the highest, based on size, it is the largest. And I'm giving the NH3 value here. I'm providing the unit explicitly since it is not added in the attribute table. So in the style I'm giving the font size and color of the text. Margin top is 0. Text align is center. Text align center is a function where here this is entire container here. Here by default it will be left aligned, so I have made it a text align center. You can give any other options as well. Next, class name for this I'm giving is subsection NH3 value, and class name for this entire top section is top section class name. Next we'll come into the bottom section. This is all the HTML content I'm explaining you for placement, like where exactly which map has to be placed. You can change it as well. In the bottom section we have two charts, that is NO2 content pie chart and the CO content bar chart. Now in the HTML.div, this is the parent and its child is this div. So in that this is the left side, that is the pie chart one, where we are giving NO2 content as the heading, and in the style text align is center, decoration is underline. You can see I've given underline. I'm giving different styles for different maps to showcase you that how it can be done. So this is not how the layout you actually follow. You have to give the same styling for all the maps actually, but I'm showing it to you because you can explore what else is there. And styling is done. Margin bottom 10px I've given. Font family, as I told, I've kept it constant. Here dcc.graph, which graph we have to integrate, fig underscore no2, that we have already declared in the Python code. For this class name I'm giving subsection of PyChart, and its parent is PyChart container. This chart, the black one is one container and the gray one is a different container. So inside the bottom section we have two containers only for the pie chart and two containers for the CO content. That is the bar chart. The CO bar chart container with heading, this is also similar. We are giving one more div and the title we are giving in the h3 size. So the style is all same again, and in the dcc dot graph we are passing the fig underscore co function that we've already integrated in Python. So the class name will be subsection bar chart, and its the parent class name will be bottom section, and its parent section will be left column. See, this entire thing is the parent section, in which the left hand side, that is the dashboard, is the left section and the map is right section. In left section we have two different section, top section and bottom section. In top section we have three different maps, and in bottom section we have two maps. So that is why I've provided the class names very precisely, because you have to understand where what is placed. In the right container, we have a div for, since only one map is added, we have a single div. The title is Bangalore Air Stations and the style is similar for everything, so I'll not be explaining it. dcc.graph is where fig map, as you know, we have declared it above. So ID is map chart and the class name will be right column, and its class, the parent right column will be dashboard grid. So now this is the HTML string content. This is all CSS styling that we have provided, like what is the width of this ozone content and what is the width of this AQI, and exactly where this has to be placed. In the above HTML we have created div sections, but we have not provided styling for it or the placement. So now this is the HTML content. Doc type HTML tag we have to open, in which we have to write header content, which consists of title, and if there are any favicons we can add the links. I've not used any. And this is the CSS. This is called as inbuilt CSS, that is inline CSS. Sorry, we have added a style section here, inside which we have created a, we have typed a CSS code. We are not using a separate file for CSS, separate for HTML and separate for Python. I'm giving everything in a single file. So body comma HTML. So for the entire body we are applying this CSS, that is margin 0. You can see in the dashboard, nowhere on the extremes we are wasting the space by giving margin. Padding is also 0. Height is 100%. As you can see, it is completely covering the web page. Background color is black, and the color, this is the font color I've given white and font family. Dashboard grid, that is the entire layout. For that we have provided display grid. Display grid is a CSS function where how you want the charts to be given. Display grid will automatically divide each division into single container. If you're not giving display as grid, then these charts will be placed one below the other, so it will not be like a dashboard. It is like a continuous scrolling web page. So grid templates column, how many columns should be present in each row. So I've given 3 columns and 2 rows for the dashboard. As you can see, these are the 3 columns and these are the 2 rows. Again, height and padding is all basic CSS. This is all CSS, and flex direction column I've given for the left column, and top section I've given display flex. Gap is 10 px, height is 320 px, and in the top section, that is dot ozone, for ozone I've given flex as 0020. Minimum width will be 220 px. This is all CSS part will be skipping, not skipping, it's like these are the functions you can explore actually. This one, if I explain, you'll not be getting it right now because it's like a trial and error method. I'll explain few functions if you need it. Justify content is the similar ones I showed you for text align. Text align function is used for only the text. Justify content is entire section or entire the division will be aligned center. And bottom section, it's chart container background color, we can give it an hex value or RGB as well. And subsection overflow hidden is if the map is more sized than the container, it will show a scroll bar um, at the down of the map. So that one we are giving as hidden. So I've given hidden for all the maps because it should not disturb my dashboard look. Map chart, this is where we are declaring style for the right section. This media query is where we provide dynamic, like based on the web page size, we are giving the um, height and width for the columns and containers. So maximum width 1024. Actually, you can change this and add more code so that you can add the width for the mobile view, laptop view, tab view. So it depends on the screen where you're watching. So this is the media query we're using for um, the screen sizing application. So this is about the CSS. This is the style where it ends. I'm not using JavaScript much here since I've integrated it completely with Dash and Plotly. So this is end of the HTML, and this is the main um, line which used to run the Dash application. So this is backend application. So if name I've given is equals to main, then app.run. App we have declared at the top while after importing the Dash, when creating an app we have declared it there. App.run debug is equals to true. Debug, if you give false, it will not show you the errors what you are getting. So I'm giving true because I need if there are any errors. So I'll show you how to run this. I'll stop running the right now. I'm inside the webinar folder. So I have the same file here. So in the same folder I have the file, so I don't need to change anything. So this is the way you have to run. There's one more way you have to run. Python Mapbox1 dot py. So this is how you can do it, but I have Python installed in different location, not in this folder, so I have to give it like this. I'm giving the Python location and mapbox.py and run it. So when you run this Dash application, you will get a hyperlink here. So when you get that link, yeah, this is the, I'm running it on a local host, so this is the link. If I follow it, I'll get the output. Follow link. It takes few minutes. This is the same I've showed you like in the previous. As you can see, IP address is same. Since that is taking time to load, I'll be showing it here only. So this is the complete dashboard we have created in this webinar. So yeah, it got refreshed. Yeah. So this is how you can showcase your web data in Web GIS applications. So there are many more ways you can create dashboards. Like you have AGSRT online dashboards as well, but since it's a paid version, and this HTML, CSS, Dash, Plotly, Python, everything is open source. I just wanted you to show how this